Good afternoon, ladies and gentlemen. My name is Nitin Dahad. Is this working? Okay. My name is Nitin Dahad, editor-in-chief of EE Times. And, well, I can't really follow that John Cooley moment, but we'll give it a try. This panel, we're going to be discussing, design, develop, dominate, the CHIPS Act's role in semiconductor innovation. And basically, we're just going to be looking at how the CHIPS Act has been helping the design industry, I guess. And I have panelists here, Vivek Prasad, Vivek representing Natcast, Nilesh Kamdar representing Keysight Technologies, and Saverio Fazzari, who assures me he doesn't speak Italian, from Booz Allen Hamilton. I'm going to quickly ask you to say a little quick intro about yourselves. Maybe I'll start with you because you can be, we go this way.
Sure.
Saverio?
So, excuse me, my name is Saverio Fazzari. I'm with Booz Allen Hamilton, which I'm going to guess most people don't know what the firm does. We're a defense firm. We focus on AI, but we do have a fairly large, thriving microelectronics business. So I lead some of the efforts, ironically doing design work and working with various clients within DoD, supporting chip design, and I have for a vast number of years working in hardware security and supply chain. And I've watched the Chips and Science Act grow in the last 10 years to what it is today. Thank you.
And then Nilesh.
Hi, I'm Nilesh Kamdar. I'm the general manager at Keysight EDA. I've been in the EDA industry about 26 years now. Work in the Bay Area, and I've spent a lot of time on design, on software, on recently AI applications, and how it impacts designers, especially in the high speed and the high frequency EDA space.
Vivek?
Hi, I'm Vivek Prasad. Is this working? I'm Vivek Prasad. I came from EDA industry for about 30 years, and now I'm working at Natcast. It's a purpose-built nonprofit by the Department of Commerce to execute on the R&D vision of the CHIPS Act. So we are the operator of the National Semiconductor Technology Center, the NSTC, and glad to be here, Nitin.
Okay, good. And I think most of you probably know EE Times. We've been going for almost 54 years as one of the leading voices. I see other people here in this electronics and semiconductor industry. So we've been covering the whole industry for over half a century. So I'm going to start. One of the things I've seen is traveling around the world and talking about CHIPS Acts around the world. There's been a lot of focus on foundries, but beyond the foundries, how is the CHIPS Act in the US reshaping the semiconductor design ecosystem? And, are we seeing initiatives that are enabling things like that for the design ecosystem? So I think we're going to explore a little bit more on that aspect. And I would say maybe, Vivek, you'd like to start.
Thank you. So this is a very relevant question. There are so many different national initiatives around the globe, and we are collaborating across all of them to learn the BKMs across all of them. But for US itself, the NSTC, the research part of it, like you said, manufacturing is all over the news. There's a lot of billions that went to Intel, to TSMC, and Samsung and Global Foundries and such. But the R&D piece of it has been split into what is being handled by Department of Commerce and what is being handled by Department of Defense. And those are the primary two pieces. And a significant chunk of the Department of Commerce initiative is part of the NSTC goals. And there are three goals there. One is to enable and foster research so that we regain our supremacy in terms of innovation through research. And this is at the early TRL levels where we are trying to promote what's the next transistor, what's the next system, but not only focus on the device side of it, but also on the design and system side of it. So that's pillar number one. Pillar number 2 is to accelerate the time from concept to prototype. And here, there are maybe 3 specifics that are important to know. One is creating facilities. So we have a EUV accelerator, as well as we are creating a pilot fab and a packaging facility, so that researchers don't have to wait for TSMC or Global Foundries to find time on their foundry cycle to get to your experiments. So we are building those. Then we have a venture fund. As you look at all the funding that Semiconductor enjoyed 10, 15 years ago, that kind of went away. And now we want to bring that back up. So there's a venture fund available that is designed to try to help bring back private equity into the market, right? So we have seen there's a growth in investments of private equity, but we want to accelerate that. So we are going to give favorable terms and assist that equity to come back. And then the time to from concept to prototyping, we are building a design enablement gateway. So the anecdotal story that I like to tell is, if you want to do a software startup, 2 people in a garage could go think of an idea, get some capacity in the cloud, build something, get customers and have money rolling in the bank. But a semiconductor startup needs an attorney first to get the EDA contracts, to get the IP contracts before they can get started, right? So that's just one of the bottlenecks. And our investment people have forgotten how to invest in a 3-year cycle. They want instant gratification. So how do we remove these expensive delays in the semiconductor development path? So that's where we are working on creating an ecosystem where we use our scale to get the right pricing and the right feedback loop into EDA and IP. But we are also creating predictable MPW schedules with the foundries.
So, I mean, you mentioned a few things there, and I think one of the things that came to my mind was, well, we've had, the small businesses, SBIR or SBRI, you've got various DARPA programs. How is CHIPS Act funding in this area different to what we had already, or is it just an extension of that?
Well, no, there's one huge difference, right? Yeah. So when you look at the DARPA programs, or even the NSTC research program, they are spending the money that is allocated. But the whole support ecosystem is supposed to be a self-sustaining enterprise that we are creating. And that's why it is not created as a government program. It's created as a non-profit startup that will allow us to create a lasting enterprise out of it for 10 years from now.
So I think you're smiling. Is there something you wanted to sort of comment on that?
Sure. Before I say something, I have to give my standard, these are my comments. They do not reflect my company or my clients. So one of the key things is what CHIPS has done is brought design to the forefront with ME Commons and things like that, with design to fab. It's forced the community to rethink, how do we deal with EDA and IP? So within ME Commons, they stood up an ecosystem to allow for access as such. But more importantly, it's getting people to think about what does this mean from there, and how do we start creating IP for innovation? In the past, there have been situations where you've developed this technology, but how do you bring it consistently forward? So the challenge is always going to be, after the money finishes from the government, how does this keep going forward as such? I think within what's happening in CHIPS and NatCast, it's a good foundation. The challenge is, okay, how do we sustain this in such a way that the ecosystem goes forward in a way that's meaningful to this community, where the investments that were put into it and the fact that the vendors are willing to participate, they continue that relationship, and the funding model works its way out in a way that makes sense.
So there's a sustainability aspect to it as well. It's not a
absolutely.
one shot. Yeah.
With any of these types of investment, eventually the initial investment will go away. So how do you bring it forward? And the challenge being, it's a short-term investment. It's a 5-year investment, as was talked about. We don't think about these things in terms of 5 to 10 years, in terms of standing up this capability.
Nilesh, do you have anything to offer?
Yeah, I'd agree with the panelists. I think we are accelerating, we are scaling up, and we are taking risks that we probably wouldn't have taken without the CHIPS Act and without the funding, right? The Commons is a great way to take this to all the regional entities. It's like 8 different entities, 6 different technology areas that we are focused on with the Commons. We would, as Keysight, we would probably not have participated in this if the government didn't set up a framework for us to do this. Another area is the AID-RFIC project. Again, we would probably not have participated this with partnership with all the different partners that we have, and pursuing design and bringing it to scale to all the members of NatCast. We would probably not have done this without the framework that has been set up so far.
Interesting. Let's move to another thought here, and that's what are the new design methodologies? I know you sort of alluded to some or tools emerging from CHIPS Act funded initiatives, and how are they changing the rules? For example, AI-driven EDA, chiplets, open source IP, 3D design flows. What are the things that are happening? And maybe Nilesh, I think you might have a little bit more of a.
Yeah, I can start on that. So I just mentioned AID-RFIC. So we walk around the floor here, you see a lot of AI, right? Every booth has something about AI. A specific program that was started is AI design for RFIC, radio frequency IC design. This is a very niche area, right? That's what my team specializes in. We see a lot of AI in digital design, in other synthesis tools, in other logic analysis areas like that, but not necessarily in RFIC. And this was a great initiative that came out of NatCast and a program that was started. And what new things that it brings to the table is, can we actually truly do design in the RF space, in the millimeter wave space, in the microwave space, where we are going after 5G, 6G, or future designs like that? And can we use AI? And historically, this is always referred to as the black cars. Even back in the day when I was at university, our electromagnetics professor would be considered the witches and the warlocks because they are practicing black arts. So that's sort of the fun part.
Yeah.
And it's always assumed that maybe you need more than one PhD to do design in this space. I think AI changes that. And
even in RF?
Even in RF,
okay,
right?
Interesting.
And so that is the program, and which is, can we come up with a way to automate RF design? Can we come up with a way to synthesize RF design? Can RF design be generative, right? We've seen some papers where you will see designs that you could probably never find in a textbook. They look like QR codes. Well, that's a filter. It's like, okay, that's interesting. Where did you come up with? Well, we just ran 2,000 simulations to come up with a design. We didn't practice equations. We didn't go with first principles. We just said, solve this problem. This is the output that I want. So very different way of doing design. This can be expanded to many different spaces. So I think this is an area of differentiation and change that is coming to the forefront.
So, what you described there, is that democratizing access to things like the black arts of RF design to startups and all those smaller companies? Is that what you're saying?
Yeah, I think anything that is common, that is rote, I think can be democratized this way. I think there's a lot of things that people do today that can probably be simplified. I think there will be differentiation coming if two different companies both have AI access and can both do similar designs. How are they differentiating? So I think we are going to invent new ways of differentiating beyond the traditional, here's a power amplifier working in your base station. There's going to be something much more interesting. And so we are going to explore this space together as an industry and go down this path.
Sounds interesting. Saveria?
So I think one of the things, ironically, is the democratization of cloud-based design. A challenge a number of years ago was how many people were still doing design and capabilities. And what I'm seeing with the clients I deal with is people look at the CHIPS investment as, now I can rethink of, I can actually do an RF design. I can do something like this from there. You bring in some of the AI capabilities that were talked about this morning as such. You're starting to see the way changes which you go forward as such from there. Because one of the key things in my mind is, how do we generate innovative IP that allows that asymmetry to occur in terms of how we do design in the country as such, especially for my DoD clients. They want that innovation that allows them to to go forward in sensing and other spaces like that. So they don't have 1,000 designers, they might have 40. So they need tools that allow them access to capability and different ways to use those tools.
And I think also I'm seeing it's not just the traditional chip companies or the chip customer companies. There's a lot wider market for these, and that's why you need more of that high level abstraction, I guess, and access.
Well, and the other part is the NOFO 2 from the packaging R&D side had one research area on EDA, which covers the whole part of that, and that dynamic that was talked about there is yet another area that I think for the design community to go after, and when successful, will change the way by which you do packaging as such.
Any views on anything we've seen out of CHIPS Act for fun design?
Well, so they covered a bunch of topics already, but I just add one more thing. So as you look at in a panel earlier today, this was emphasized that because of the AI influence, smaller teams are able to do innovation that was not feasible before. So even small teams in universities are creating a lot of innovation. So now that's bringing the industry to universities, so that where the ideas get spawned and then the industry is helped from there. So it's democratizing it even further at a granular level that was not possible without having these type of tools available.
Talking of democratization, does anybody have a question for our panelists on that? Otherwise, I'm going to move on. Just have a look around the room. No. So the next thing is around how do you collaboration versus competition? How do public-private partnerships and through programs like the Microelectronics Commons balance IP protection with open innovation? And I think you had some interesting views earlier, Saverio, so interesting to see what you'd like to publicly say.
So I think part of this is the evolution of these things to find the right niche to work. The IP protection piece is a critical part of it, and developing an IP model that enables that innovative research is something, and my experience is if you address it up front, you will be successful. If you wait, it prevents that success as those projects become contained and you don't get that sharing and innovation as such. What we're seeing now within the Commons are people starting to figure out how to make that happen the right way from there. The challenge will be, as you move forward, how does that become a product and how do you deal with that stuff? So I know particular organizations that are, have the IP lawyers and other people in place to figure out what that model looks like. Because ultimately, for many of those folks, it's okay, how am I going to make money off of this thing as I go forward with this from there? And it's still a challenge to figure out. From an R&D perspective, it's great, we've achieved our goal, how do we move forward?
Yeah.
So I think this is a multi-billion-dollar question, right? And it's still not a solved problem. So you have to look at research from a pre-competitive space first, where you really need collaboration, not only within the US, but across
we see it in the UK as well.
So that global pre-competitive collaboration needs to happen to really further our technological capabilities. And then once you start to get into competitive space, then funding is needed to support maybe the technologies that will come 3, 4, 5 years from now.
But how do you bet on those?
Well, this is where we need the collective thought, right?
Yeah.
So NatCast, our research group, has a technology advisory board that has like 15 members from around the academia and industry and the government programs. So collectively, and we take feedback from the general public as well to see how to inform our investments. And we created a very new program for scalable memory architecture, right? It's not about designing a memory, but the architectures for the future, which is again a bit pre-competitive, but there may be certain competitive ideas that come out of it. So the IP part of it is yet to be defined.
I mean, that's actually very hard, because where does it become a competitive advantage? And I don't know if anybody wants to talk about that.
So I'd offer a couple thoughts.
Yeah.
One of the things I've seen work on a smaller scale is failure is an option. Again, you look at the things you may bet on 3 and 1 fails. Is that a bad thing fundamentally, or are you advancing state of the art that those other 2 become more successful? Other efforts have focused on coming up with a validation process, so whatever you choose to have out there, you have a way to ensure there's interoperability and it can work within a solution as such. So as opposed to investing heavily in a potential set of solutions, you invest in the ecosystem so that the strongest will rise to the top.
Yeah, I think collaboration and partnership first, right? So I believe at this point of time, what we're trying to do, put in a lot of investment in the US in semiconductor space. We probably need to do a lot more collaboration, and there are many different partnerships being set up. I represent EDA, but I partner with a lot of other EDA companies. As part of some of the programs that we are part of, we are partnering with several universities. We are partnering with startups, which we rarely do, which was a great experience. We've actually got an opportunity to partner with another company that's offering fab services to fab out chips. So there's a lot of interesting, unlikely partnerships that come into play. I'm sure competition spirit will rise when the foundation is laid. I'm not too worried about it. I think we have more than enough space, more than enough market to survive all of this.
So, one of the questions I wrote here, and I'm not sure if it sort of follows from this, but let's have a go at this. What guardrails or governance mechanisms are in place to manage that tension between collaboration and competition? And I think I sort of alluded to it earlier. Maybe.
Well, I think the guardrails are still being defined. I put it that way, right?
Yeah.
So the whole IP strategy, there's also this distrust of taking government money, because what type of strings come with it. So we really need to write down our IP strategy, and we want the certain IPs to be available so that we don't create patent sort of silos that exclude a whole bunch of other people, right? So there are certain foundational IPs. If we invest in those, they should become enablers for the entire industry, while there may be certain vertical IPs that could be competitive, right? So this is still a work in progress. We are defining it.
I'll just say, going through this right now, working on a program, we basically had to hire multiple people to tell us what is foreground IP and what's background IP. It took a lot of work. It's not easy, but we can get it done. We can figure it out. But IP management is important because as part of the program, we want to contribute back to the members, back to NatCast, whoever's running the program. But we also want to make sure that whatever was background IP is kept background IP and sustained. So that is a interesting conversation. There's also data management, which is another thread. Maybe we can talk about later. There's IP in terms of maybe EDA methods or technologies or design. What about data itself? And who owns data and where does that go? And I think the government, through various programs, has been trying to collect data sources together so that we could use it for training potentially, but there's a lot more that could be done here.
I asked this question to one of the EDA companies a couple of years ago when they launched an AI platform, and I said, how about sharing some of this data anonymously so that everybody can use that? And I think that was obviously not commercially, I think it was not something that it would have been entertained yet. So it's quite interesting.
Unfortunately, I think what's been said is very valid, is that this is a work in progress, because it's not just figuring it out, but it's also the education of the community so they understand the dynamics there. One of the challenges I have is, okay, you paid for use of this IP, you didn't pay for ownership of this IP, and how is that model going to work as such? Because yes, we all want to use it for training. What does that truly mean? How do you do it? So there are programs that look at ways to get access to encrypted data to do analysis on and things like that. But in general, I think it's a tough question. What I look as a positive, people are talking about this, trying to figure this out. It's not an ad hoc thing. You're seeing it through NatCast, through Commons, and other activities. So I think you're starting to see people coalescing on best practices and things like that. And I believe in the next couple of years, people will have a better feel on how to make it happen.
Maybe I'll just jump in. I totally agree. I think we're still figuring this out, right? If you all pull out your phones and you order a ride share from here to the airport, right? You know what's happening. That data is going in the cloud. And the company that you choose, they're going to use that data. And they're going to train it based on your behavior, the credit card that you use, and they're going to do something with it. What do you do with design data? You ship a chip. Nobody else has access to that. That's not in the cloud historically, right? Maybe it's in a private cloud, maybe it's in a secure environment, maybe it's within your company. Can anybody get access to the data? If not, why not? And what happens? This is the toughest question, right? And everyone wants AI that has been trained on other sources but not theirs, right? So it's a nice tension that has been built up. I think we're still trying to figure out ways to break through this.
And by the way, so Natcast, with our tools in the cloud strategy, data aggregation is an important aspect, and we are defining it with our membership.
So that could lead to that sort of platform which is open for people to tap into.
Correct.
Yeah, they do that in the connected autonomous vehicles industry, where in the UK there's a shared database of all the miles.
Yeah.
So it's quite interesting. Does anybody else? I think if the mic's working, just step up to the mic and try. Oh. One second. I think the lady behind is.
Uh-oh.
Yeah. Okay. Oh, it's not working. Oh, the lady's
We
just coming.
lost her. Oh, there we go.
No? Okay. Well, if she works, then you can come up later. What does success look like in terms of ROI, return on investment, not just for the CHIPS Act investments, but for private sector participants? And investors always want measurable impact. So how does that look like from a Natcast point of view? And what are you seeing also, maybe? So maybe we'll start there.
So from a Natcast perspective, I'll maybe just take the goal number 2, which is accelerating from concept to prototype.
Yeah.
So this is a metric that we can measure what's the typical number of quarters to get to a successful prototype, and then we are going to actively measure how we are removing some of the bottlenecks along the way, and not only saving on time, but also saving on the amount of the idle headcount dollars that are spent when you are waiting for certain the next milestone to become available for you to act on. So that's one of the metrics that we are measuring. In addition, we have our research metrics and our workforce development metrics. So we just UCLA, our CMID program, they did like 230 tape outs this year. They are now on track to do more than 1,000, supporting more than 1,000 classroom tape outs next year. And they are training new professors in 22 universities on tape out classes, right? So that kind of exponential growth is what we want to track as well.
And how are you going to follow that tracking? What kind of metrics are you going to look into?
So we are still in our month 7 of our planning and implementation. So by the end of the year, as we go to production with our platforms, all of these metrics would have been vetted with people like you all as well, and to see exactly what should success look like. We have our initial set of metrics defined.
So maybe I'll just say there's maybe different time horizons for what success looks like, right? In the short term, I think most of the success is around new technologies coming to the market. Can the government sponsorship, CHIPS Act, can it bring in things different, faster to the market than we were, or whatever path we were on before? So AI is an example. There are many other examples, but can that come to the market? Personally, profitable revenue growth, right? A company that, public company, that's one of the metrics that we would look for. But if I look at the more medium term and the longer term perspective, it is what's happening in the industry. Does the CHIPS Act fundamentally change what is needed in the industry? Are there more PhD programs working in semiconductors? Are there more things happening for material science and research in universities in this space? Are there more startups coming up that are going to do active silicon design and semiconductor design in this space? And is that pace of change in the marketplace, change in the industry faster than what we had before CHIPS Act, where a lot of things was assumed to go overseas, assumed to go to Taiwan or Japan or some other place overseas, and does this change that? So I'd see ROI in maybe those ways.
But you see ROI, but are there things defined already? Any early KPIs?
Again, as I said, from my perspective, it's innovations coming to market, and then selfishly, sustainable, profitable growth. But yeah.
Okay.
So shamelessly, workforce development. There's a workforce crunch. It's easy to measure. There've been a number of programs that I've seen work with clients and such, and we feel we're closing a goal. Whether that's a good metric or not, I don't know, and that's one of the challenges right now with everything that we've talked about as such. For many of the cases, it's the impact to the mission and the particular program you're working on. ME Commons is closing that lab to fab gap, meaning a dual-use technology that's impacting modernization within the capabilities of the requirements as such from there. Certainly profitability and other things that are mentioned. I think part of the challenge is, does this change the industry in such a way that there is a renewed growth within this space, because it's decaying somewhat as such, and that innovation is not occurring as much. You see too often US-based companies are opening centers overseas to facilitate that innovation. So my hope and belief is the CHIPS Act will change that they can open those centers in the US and enable that innovation in the US.
I mean, I travel to places like India, and I see they take pride in sort of what their global competence centers now, they call them.
Yep.
Basically, effectively, the offshore design centers. So you've got that where they're growing that aspect, and you've got CHIPS Acts in US and Europe where they want to do things within the country. Can you actually see a lot of that coming back into the US?
So anecdotally, you're seeing more students in US colleges and master's PhD programs doing design-related activities as such, looking for jobs in the US. You see commercial companies hiring within the US because of patent laws saying, if I build and design it in the US, I can protect it better. So I see it. Can I measure it at this point? No.
So this is, you're touching an important point, that maybe talk about manufacturing leaving the US, but there's also been this exodus of innovation that has been leaving the US, primarily for cost and talent reasons, right? And cost used to be the primary driver.
But now it's talent.
Now it's talent.
Yeah.
So by our workforce initiatives, if we build the talent here, we'll be able to keep some of the innovation in-house. But we also need to move away from the centers like Silicon Valley and Austin and such, right? We need to expand where innovation can happen within the US, where the cost could be better managed as well. And together...
I tried to go to Austin and then, where else? I don't know.
So we went to Austin. Now Austin is expensive, so where do we go? So compare that to India. Bangalore went to Pune, Pune went to Chandigarh and so forth, right? So they went from tier 1 to tier 2 to tier 3 and tier 4 cities. We need to create the same pattern over here.
Yeah, I totally agree. I think workforce development is key here. I do agree that there are some green shoots. We are seeing more engineers enter the PhD programs, the master's programs in US universities working on projects. But I think the pace at which some of our members are retiring out of this industry, engineers that they would do semiconductor IC design, that's also quite high. I think some of that even accelerated after COVID. A lot of people just, for many other reasons, decided they're going to take early retirement. That's created a fairly big gap. Okay. So whatever is happening is great, but I think we need to do more. I think, again, the government investment and putting a spotlight on this space is great, right? If you look at Silicon Valley, right, there's no shortage of money if you're doing an AI startup today. If you're building the next challenge to OpenAI, you get $1 billion, it seems, instantly. And the government is probably the last bank standing that says, let's do it for semi also. Let's do it for design, let's do it for IP. So I really like that.
So you're talking about the lack of experienced talent, leaving the industry as well.
Yeah, there's a lot of that too. Yeah.
So can I make a cautionary comment?
Yeah.
I don't think the government is the last bank with $1 billion that's going to hand it out. You know, the money now is what the money is now. It's the question of, can the community use that as the match to start the fire to go down that path? And part of that is, you know, Natcast came out of commercial industry pushing the government to make this happen. So how do you keep pushing this forward to have the different touch points in the power grid in other areas where you need design that has innovation as such? I don't see in the current administration an environment that you're going to see another 300, whatever the number might be, dropped into this space when they're saying, look, you know, foreign companies are investing $100 billion into the US. It just needs to be a collective to go after this in a way that says, you know, we're ready and we're going to be aggressive on making it happen.
I'm just going to follow on, and I see we've got a few minutes left. The talk about talent. And one of my questions was going to be, what role do academic institutions and regional innovation hubs play in building a sustainable, inclusive design talent pipeline? And I think we addressed some of the talent issues, but are there partnerships with universities? I think you mentioned one, but and community colleges that are being structured now, and how they're being structured. I don't know if you want to talk to that a little bit.
Well, so I was talking to one of these tape-out helping outfits that's based in, not in the US, and they do about 1,000 high school tape-outs a year. And less than a handful of that comes from the US. So how do we create a pool of talent that is actually even interested in this? But if you try to catch them when they are a freshman in college, it's too late. So you have to generate the interest earlier. That's one thing, but at a university, the partnership with university needs to also be, because a lot more blue sky research happens there. We need to find, there's a ton of investment in AI, and industry is funding that already. I don't think we need government funds or the small research funds that universities have to support that. But where are the gaps? We need to find where are the gaps and where's the transformational technology that will get us to be the innovation leader. That's where partnership with university is going to help the most.
I get press releases from Arizona quite regularly. They seem to be very active in that area.
Yeah.
Saverio.
So, you know, Arizona is a great story. They have a mission and a vision of how to make this happen. I think the challenge also with workforce development is simply directed. You know, in many of the studies, they say you need the jobs within the adjacent zip codes. You can't be developing people and the work is 1,000 miles away. So we have to be finding the right places where people can go to work. Yet if you go in Arizona, they say, we don't have a workforce problem. We've got people being laid off from one company. We can hire them pretty easily from there. So how do we sort of ebb that out in such a way that we grow the workforce in such a way that we have that positive impact?
Yeah. Nilesh?
I'll just say, at a very personal level, we are going through hiring for interns right now. So that's another direct way that we are impacting the future workforce. We have people that we need that do semiconductor design. We also have people that build design tools and EDA tools and AI tools for the future workforce. And Keysight participates in this. I am intending to do bigger push into this. Even the government program has actually invigorated the opportunity to go after some talent as we are doing partnerships. And UT Austin, for example, is providing us with some technology as we work on a program together. We are also spotting students and future workforce people who can actually develop solutions for us. So I see that at a very maybe macro level, micro level going on for Keysight. Yeah.
Do you think, aside from things like, and this is now a personal thought, aside from things like CHIPS Acts, whatever, these large corporate organizations, companies could be doing a lot more?
Absolutely.
And I'm not targeting Keysight or anybody,
but in general, yes, absolutely. I think there's a lot of opportunity to fund continuing education for people within corporations. I think there's a lot of opportunity to sponsor PhD programs or research grants and stuff at universities. And we've had history of doing this for many years. As a company, we may have contracted a little bit, but there's an opportunity to do more in this space.
I remember when I was studying electronic engineering in the 80s, most of my cohorts used to be like sponsored by companies, and they were doing their full degree electronic engineering. So I think that's got lost a little bit. Let's leave closing thoughts. Who wants to start? Saverio.
So I think two things. It's an opportunity, and I wish people would grab it. And the cash is one thing, but the question is, this NatCast environment, how are you going to leverage it? That's what I worry about. People should be thinking about what NatCast is doing. It's great to be part of, but how will that impact whatever you're doing and where you can leverage the ecosystem that they set up as such? People worry about competition between other things. I would suggest that will get worked out. It will not get worked out as fast as you expect, but people recognize that customers need to understand how these things coexist. And I know for a fact those discussions are already ongoing. But I'm excited. This is the first time the government has recognized the need in this space and invested. And if the industry does not take advantage of it, shame on us.
Nilesh, closing thoughts.
I'll just say this is an exciting era to be in, great opportunities. The government is definitely leaning in. I think industry, research, universities, we all have to reciprocate. I think right now for Keysight, this was a unique opportunity to participate in one of the first programs that came out, and we've learned a lot. And I'm telling you, partnerships and technology innovation is driving our excitement in the space. So,
very good. Last word with you, Vivek.
Well, I was giving a graduation speech at one of the high schools here, and I was telling the kids that they are in this era of very fast transformation. So they'll see much more transformations in their lifetime than we all did, right? So so that's why it is exciting and yet daunting at the same time. So we are in this space here where there's opportunity and there are solutions that we are trying to provide, but it's based on everybody's collective problem statements. And I behoove everybody to make sure that they are connecting with us, to make sure that we are looking at your problem statements and not solving problem statements that we have just in our heads. So please be a part of the solution and come to us. And together we want to make this a sustainable enterprise with a 5-year funding, but with a 10-year horizon of sustainability. So we look forward to that.
We wish you well in all of that, and it sounds very good. Well, I'd like to thank all the panelists here. So thank you very much.